So hi, I'm Sandeep. I'm engineering lead data platforms. Today we're going to talk about journey on building a data platform and embracing data mesh. Before we jump right into our talk, I would like to give an introduction about Dojo. So we are one of the fastest, one of the largest fintechs in Europe by net revenue. We process almost 15% of payments in terms of transactions in UK at the moment for face-to-face. We are mainly focused on experience economy of bars, pubs, restaurants, even your local corner shop. We also have a customer-facing app where you can actually queue virtually in a restaurant and then book a table and then go and eat there and pay as well. We have amazing products. We have tap to pay, pocket pay, face-to-face pay. We also provide funding to small businesses. And we are building many, many more products going forward. We are also going to be launching in Europe. So we're going to start with Ireland, and probably you're going to see us in every corner of Europe as well. What makes all of this possible is that we are highly, highly data-driven, and we value insights in our decision-making. Now, I love this picture. The world's most valuable resource is no longer oil, but data, right? Everyone wants to collect data. Everyone wants to, target right customers by doing proper insights. You go to a shopping center, they ask you, oh, give me your email address, I'll give you 5% discount, right? So everybody is mining the data. Everybody's trying to get the data, but collection of data is not everything. And you have a lot of data endpoints in your company as well, where your engineers are generating a lot of data. But collection is not everything. You have to store the data properly. You have to make sure data is accessible in quick manner by the right people so they can make the right decisions. All of this is possible if you have a kick-ass data infrastructure, right? Now, before jumping into the modern data infra and processing and data mesh and everything, let's look at the history of data processing. So there are mainly three generations. First generation used to be the enterprise data warehouse, where those big, beefy warehouse, IBM, Microsoft, and Oracle, they were building those big, beefy warehouse where only few limited people would understand the technology and very few people would actually use it. Then the era of big data system came, where we had Hadoop and its own ecosystem. Pig, Hive, Spark came into the picture. We started building these big, beefy centralized data platforms to process data. Then the current generation, which is a central data platform, right? Which is mostly combination of batch and real-time processing tools like Kafka, PubSub, based on Kappa architecture. Then you have Apache Beam to give a flavor of batch processing as well. Then you have cloud managed services, so a lot of tools being provided by AWS, GCP, Azure, Oracle as well. And then you have some other key players in the market for like Confluent, Avon, Red Panda is there now for streaming. All of these came and we are using them right now to build this centralized model. Now, the centralized model can work for organizations which have like few domains, not scaling very fast, but when it comes to diverse number of consumption use cases or enterprise rich domains, a large number of sources come into the picture, and then a large number of consumers come into the picture. Then the centralized big monolith data platform doesn't scale. Now, there are a lot of challenges, extra challenges with centralized data platform. One of them, a centralized team. I think somebody also previously talked about the same issue, that we have a siloed and a stretched data platform team if you have a central data platform. Because you are the people who are owning the data pipelines, who are owning kind of data contracts hand in hand with the stakeholders, and also fixing issues, looking after the support. And then you have a huge backlog of requests coming from stakeholders which you have to fill. So you don't have much more time unless you throw 50 more data platform engineers to build some new features and new tools. Then come in data quality, which is again somebody previously talked about, the how much is the trust important in terms of when it comes to data processing? If I'm a stakeholder, I would like to believe that this data is correct to make those good decisions for my business moving forward. So when there is no accountability for who owns this data pipeline or who owns the data, stakeholders don't want to put data quality measures, and data platform team put data quality measures as much as they know. So at the end of the day, you have a data lake or data warehouse which might not be accurate. Then comes scalability. Now, when your organization is going through big changes, you're adding new sources, you're going international, you have legacy systems to incorporate, so much stuff, right? Then if you have a central team who's doing that work for you, then they will have a huge backlog. And that will become a bottleneck as well. There is one more point there, data access. If the data access is also managed by a centralized team, they are again a bottleneck. Like, I am a stakeholder, or I am an engineer, I want to access, or I'm an analyst, I want to access a piece of table or a piece of file to do something quickly. First, I have to raise a ticket to them, if they're free or not, if they're on lunch for 2 hours or something. I don't get access to the data straight away, and I lose that crucial time where I can actually, utilize that data and make some sense out of it. So how do we deal with this? What if, imagine a world where the centralized data team will only focus on creating a generic data infrastructure or a self-serve data platform. And by self-serve data platform, I mean is that abstracting away all the complexity and enabling the teams to process their own data. Now, apart from that, they can also provide a global governance model where they will decide the better naming convention, better access management policies, the security, the better CIs, and so much other stuff. At the same time, in that imagination which we are right now, we also transfer the ownership of data processing to the domains. By domains, what I mean is the certain teams or certain people who are working on a certain business department, like payments, consumers, marketing, And what happens after that? Once that happens, finally data is owned by the people who understand it better than the centralized data team. Scalability is not an issue anymore because we have stretched the data processing to the domains. Now domains are able to add new sources. The access is not an issue anymore. Domains can give access to the people who are required to have access to that data. Then fixing of issues, fixing of support and everything also becomes very easy because the domain handles its own data pipelines. Then this approach will also enforce well-documented data contracts, data APIs, which will allow data to flow seamlessly between domains. Because at the end of the day, you want cross-domain products to be created. Not just payment is producing the data and the payment is only going to use it. There will be some other payment experience or customer team who wants to use how the payment data is behaving so they can target more customers, things like that. So that is very important as well. And having domains owning their infrastructure brings more visibility on resource utilization and allocation, so the cost efficiency also becomes a factor. And this could lead to less cost on infrastructure or less cost on cloud. Now, basis actually is data mesh. Data mesh was introduced by Zhamak a few years ago from ThoughtWorks. It has 4 pillars, which the first one is domain ownership, which we just talked about it. It's your data, you are producing it, you are the stakeholder, you own it, you process it, you manage it, and if shit hits the fan, you fix it. Not the centralized data team, which they don't know anything about it. The second thing is data as a product. So don't consider data as a byproduct of your features, of your work. Data is a product, and either it's a simple event or a simple topic or a single file or a big table or a warehouse, everything treated as a product. Then you have federated computational governance, which is allow the domains, so you have a global level of governance where data teams set certain standards, that this is how you should name, these are the security policies, this is XYZ, but then the domains can also set their own policies. Let's say the payment domain wants to set a policy around PCI, which is payment compliance. They can set that. Then marketing or customer domain says, okay, we have the data of these customers, but after 28 days, we just want that to be deleted automatically to be in GDPR, so they can set their own policies. So you provide that framework for them to do it, so you don't have to do it for them. Then the self-serve data platform, which is my favorite part, is that's the key to all of this. So if you build a successful data platform, 80% of your problems might go away, and 80% of data mesh can kind of like achieved, right? But it's still very challenging. How are you going to build a data platform? Today, in this modern world, where we talked about so many managed services, so many tools, that it's so difficult for an engineer or for a leader in data space or anybody to actually pick the right tool for their data processing. And if you look at it, this is from MAD. It's actually MAD. This is ML, AI, and data landscape, and that's why they call it MAD. But and I call it that modern data stack is actually broken. If you look at the number of tools and number of solutions out there, it's bonkers. It's so much. And for an engineer and for anybody to actually understand and fit them into their use case, it's very, very difficult. And then, on the other hand, all of these companies have hired sales agents and everything. They message you on LinkedIn. They say they have the best data platform. And trust me, no one has a best one-stop solution for your use case. You still have to manage the managed solution as well. So what should we do? Our recommendation is build small and then go big. So you choose one of the cloud provider or multi-cloud provider, if whatever works for you, and then probably build features or components by testing your use case by utilizing open source tools and technologies. There are a lot of open source tooling is out there for data processing, for data platforms. You can utilize that. You can try to build it. Then get an early feedback from your stakeholders or within the team or with other engineers that how it works, does it make sense, are we going in the right direction, yada, yada, yada. And then you have Kubernetes can be your friend. Like most of the tools you can easily deploy with one click by using Helm charts or anything, and it's like a little bit of configuration, and YAML gives you a lot of power, and then you can start playing around with your architecture, which you just decided as a data platform. And then you still need to use managed services because you will need a bucket, or you will need like Redis managed instance or something. That is up to you. When you see that the operational cost is higher, like you need 3-4 engineers to run, let's say, a Kafka cluster somewhere, I would rather go with the managed service because they will be managing it for me, and overall it's going to cost less than what it's costing right now. Then there's final point, you can be cloud agnostic or multi-cloud, so you don't just hooked into one piece of technology and just stay there. And also these days there are a lot of outages happening on the clouds as well. Especially in London, we have seen like regions going down. So if you have high availability use cases, you might want to think about being multi-cloud. That's not just it. Data mesh also brings its own different challenges, right? I guess in a previous talk, somebody talked about a cultural shift. Yes, it's a concept. Centralized data platform is a concept where we are actually spoon-feeding the domains. We are doing all the work for them. So if you say, oh, from today onwards, we are not going to do any work for you guys. We're going to create this self-serve data platform, and you're going to come and use it. They're not going to like it, right? So it's a cultural shift where you have to have leadership buy-in, and then the movement should be from top to down, that and then people will understand and people will move forward towards this direction, right? Sorry. Then, sorry. Talent and skill gaps. Now, building this data platform, you need data platform engineers. Data platform engineers can be specialized in platform skills, can be core software engineers, can be core data engineers, or can be horizontal. You can have guys like who knows everything, and they can lead those projects, right? So finding those people is very crucial. It's very difficult. It can be complex. So yeah, that's another challenge. Then you have data governance complexity. Now, it's very easy to say we can put a governance on top of everything. This is the naming convention you have to follow. You have to do that. But implementing that is challenging. It's complex. Then you need to think as a product team when it comes to data mesh tooling. You are building a product, so you need to build services. You need to think. You might have to put a UI on top of your service to make sure it's easy. You might have to integrate with, might have to build some custom Kubernetes operators. So when engineers are writing their services, they can write few lines of YAML and it get hooked into your platform. Then you have data integration. Various domains and sources can be complex. So you have data is coming from multiple different file formats. Or data is coming from multiple different sources. They have their different API definitions. You might have to support most of that as well. Then one of my favorite is data cataloging and discovery. So when your organization is going through a big growth, effective data cataloging and discovery mechanisms are essential in data mesh. Because they ensure that the consumers can actually find what they're looking for pretty quickly, rather than juggling around and messaging 50 people in the company, finding out who owns this data source, what is the business glossary about it. It becomes tedious. Then ROI, return on investment measurement. When you implement data mesh, you're not going to see the benefits right away. It's going to take some time, and you have to have that patience to see that this decentralized approach actually works. And it does, trust me, it does. Then you have legacy system integration. So everybody have legacy systems. I haven't worked in a place where I haven't had to deal with some legacy systems, hate them. You still have to integrate those legacy systems within the data platform so they can actually be processed. And sometimes what happens is nobody owns legacy systems. There is no domain. So you as a data team might have to step up and say, okay, fine, we're going to own this piece until we figure it out who's going to own it in future, right? And you might have to make that processing very simple and easy, so any other engineering team say, okay, you know what, it belongs to our domain, we will own it now. So it's not that hard rule that all the work has to be done by domains. You might have to be a bit more flexible there as well. And then overcoming these challenges requires a well thought strategy. Strong leadership is very important when you want to push towards data mesh. And a commitment to the principles of data mesh. There are only 4. And you have to educate your organization, your engineers, and tell them constantly like what you're trying to do and what you're trying to achieve. And eventually they will understand. This is how it looks like at Dojo. So we don't have a centralized data platform. I just mentioned it there just to showcase what we have. So see on the left and right hand side, you have domains. Domains are producing the data, and domains are consuming the data. Domains are building products in terms of analytics, artificial intelligence, ML, or external integrations where they might want to share data with external customers. Then in terms of processing, you have 2 types of data which we think we have, like files or events. Then you have streaming platform to process the events. You have file platform to process the files. You have PCI platform to handle the PCI PAN masking, the credit card number masking. Then this whole platform or whole code, generic code, also provides catalog, schema registries everywhere, whether it's file, whether it's events, so the data contracts are not broken. They're there. Then data observability. Then you have quality, data quality functions where people can actually go and write, this is the quality measure and this is how the data should look like. Then the governance model is there. Of course, self-serve features, platform observability, which is very important because some of the workloads, because we are very heavily Kubernetes based, some of the workloads or operators might be running in the domain clusters, so they have to send the metrics, and then that has to be captured somewhere, and the alerts have to be configured. So we provide those global alerts. So you just deploy it, automatically the global alerts are set up, and we will get alerted if the service goes down, and you as well. And then finally, the developer experience, which is the key to everything. So if you make things super easy for somebody to adopt, people will come and adopt it. Yeah, thank you for your time. We are still hiring. We have a lot of data platform engineering roles open, analyst roles open, engineering managers, and so many more roles open. So please go to the Dojo career page, or you can just directly DM me if you want me to refer you somewhere, and I can do that for you. Thank you so much.